welcome everyone who has been able to join us today. This is super exciting to have. We have both Daniel Diaz and Oscar Reyes from Tracetest joining us today for OTel Q&A. And we haven't had an OTel Q&A for a while, so I'm so glad that both of you were able to join us today. For those of you who are here today, thank you for joining. And also tell your friends that we will be posting a recording of this on the OTel YouTube channel. So that's OTel-official for anyone who couldn't make it. And we'll also provide the links on socials once the recording is made available. So with that, let's get started. Why don't I get you to introduce yourselves?
I can go first. So, hello everyone. I'm Daniel Diaz, a Brazilian living and complaining in Argentina right now because of the weather. I am a software developer at Tracetest, and while I'm not helping the team to evolve with new features, I'm bragging about the features somewhere. That's all.
And Daniel he's also an ambassador, so we're really proud to have one ambassador
I am
in the
a
team.
CNCF ambassador too.
CNCF ambassador, right?
Yes.
Yes.
Newly minted, right? Just
Yes, I became an ambassador last month.
yay, congratulations.
For my part, I'm Oscar Reyes. I'm Mexican. I live in Mexico, and I'm a lead software engineer here at Tracetest. And yeah, I'm really happy to be here and talk about Tracetest and OpenTelemetry.
Awesome. Okay. Well, I guess first things first, for folks on the call who might not be familiar, can you tell us what trace-based testing is?
When we say about trace-based tests, the main idea is that we use traces emitted by systems to assert how the current state of the state is. So we call some component on the system, wait for a while until the trace is generated, and we start to make assertions to this trace to guarantee that everything is right.
Yeah, and this is really helpful for distributed services where you have a lot of moving pieces. And if the entire system is instrumented, you can have a lot of assertions around the generated OpenTelemetry data or the traces, right? You can validate that certain spans exist, but you can also go deeper and validate things like the attributes or the execution time of the spans, those sort of things. So it's a multi-layer level of testing and the entire spans or traces that your system generates.
That's awesome. And you know, the thing I love about trace-based testing is like we're already emitting traces in our code. So why not take advantage of that? So I feel like it's a 2-for-1 deal, which is very awesome. The other thing that I wanted to ask, so how does Tracetest implement trace-based testing?
Maybe I can answer this one and you can complement what I say, Daniel, if you want to. So the way that Tracetest does it is that we have a 2-step process. The first one is triggering your system, the system under test. Currently, we support things like HTTP, gRPC requests. We also support Kafka that was actually integrated by Daniel. And then we have other type of integrations for other type of systems like Cypress or Playwright. So that's kind of the first half of what Tracetest does, triggers their system under test. And then the system under test will need to generate those the traces and the spans and put them somewhere in a tracing backend. Tracing backend, it could be something like Jaeger or Tempo or any other providers that you will store the traces. And then the second half, or what Tracetest will do, is pull for those traces based on the configuration that you have. So we will wait, depending on the way the system works. There are systems that generate all of the entire trace in like one couple of seconds. You have other ones that have long-lasting processes that could take 5 minutes. So we support all those variables, and so we wait for the trace to be ready. We pull that into the Tracetest system based on the trace ID that we generate on the first step that will work as the parent ID. and then the assertions on the spans, the sessions and the test space will be triggered against that generated traces or telemetry data. So I guess, well, there will be a three-step process: trigger, trace or getting the trace, and then test. That's how we're calling our three-step process.
Cool. Danielle, do you have anything to add on to that, or you good? All right, cool. And if I remember correctly, because it's been a while since I played with Tracetest, but you can create your trace-based tests using YAML, right? Everyone's favorite thing that they love to hate.
Yeah, exactly. So I think one of the things that we have kind of pushing in the past few months is not only allowing things to have these three steps, but also how they can automate and simplify the way to introduce trace-based tests in their systems. Either if you use it through a system of Git actions or CI/CD processes, sorry, or if you have them in a I don't know, in a cron job, with the automate way that we provide, you can use our CLI, you can use the different tools that we provide, like our TypeScript library. So you can pretty much graph the specifications and the YAML files, as you said, even JSON files from the system. If you go to the UI or either use the CLI to export them, you can put it in your repo and execute everything from there. So it's like you have multiple ways of interacting with the system and with the test definitions, either through the UI, through the CLI, or libraries that we also support.
Cool, awesome. Before we go on, I do want to mention to folks who are watching, if anyone has any questions, do feel free to pop them into the chat, and we will also have like a Q&A portion at the end. I just wanted to mention that quickly. Okay, so I guess the main reason why we called Danielle and Oscar to do Q&A is that they did something super cool last fall, which was they integrated trace-based testing a la Tracetest into the OTel Community Demo. So first of all, can one of you explain what the OTel Community Demo is for folks who aren't familiar with it?
I can answer that. The main idea of the Open Telemetry Demo is that it emulates a telescope shop, but with one major thing. Under this shop, we have a bunch of microservices that interact with each other, each one with one responsibility on the system. So we have one API to make payments, another one to do shipping and everything else. And the main idea of this demo is just to show with a different technology, a different language, how you can integrate OpenTelemetry to your system and how you can see this data integrated across a bunch of microservices.
Awesome. Yeah, and it's a great way for getting started with OTel, like especially if you're like, oh, this is so overwhelming, seeing it in like, a relatively complex sort of example just goes to show like the power of OTel, which I always think is so cool. And it's not terribly awful to get started with the OTel demo. So I definitely recommend to folks who haven't tried it out to give it a go. Okay, so now that we understand what the OTel demo is, let's talk about how you got Tracetest integrated into the demo.
Maybe I can start with the first half of the story, and then Daniel can continue after that. So almost, I guess, a year and a half ago, we were looking for different partnerships or different ways to contribute with the community and just push OpenTelemetry further. So we discovered the OpenTelemetry demo, and so I was on a task on kind of let's try to just contribute and see how we can help and how we can grow the community. And the first thing that I worked on, it was to switch or migrate the existing front-end application that was built entirely in Golang with a server-side render front-end, just templates, HTML templates, things like that, to an actual front-end application. So I switched that from Go to Next.js. So Next.js on the having React involved, and also introducing the actual front-end instrumentation of the application by using the tools and the web, the browser side OpenTelemetry libraries. So in that case, it is continuously connected across, starting from the browser all the way to the backend services. And that was kind of pretty much my contribution, my initial contribution on the OpenTelemetry demo. And then after Daniel joined and did other stuff. So you want to go next, continue, Daniel?
So after a while, we started to see the OpenTelemetry demo because it is great. Every time that you need to see, oh, I will start programming in Ruby and I need an API. If you go to OpenTelemetry demo, you will see a Ruby API there, and you can say, oh, this is how we integrate things there, or Python, or everything else. But looking to the tests that we have in OpenTelemetry demo at the time, they had integration tests, but just on the API level. So we could test some features of each API, but we could not see how they act together. And sometimes this is painful, mainly when you have background process. For instance, if you have an API that emits messages to a Kafka query, and you have another API that reads data from this Kafka query, how do you guarantee that this second service got the message correctly and is doing something correct? We did not have this at the time. And looking to this test, I thought of, what if we do a trace-based test? So we started discussing a little bit. One of the members of the OpenTelemetry team also, demo team, also asked us, because they say, oh guys, we developed some new things on the OpenTelemetry demo, but we not noticed that we changed the slide a little bit, some traces, and something is weird to understand. We need to manually inspect everything. So we started to do trace-based tests on that. We started looking each one of the integration tests, and we started writing a counterpart trace-based test, but with a small difference. Instead of just seeing the API response, we also are seeing what are the APIs that we are calling behind the scenes, and we are testing these APIs too.
And so my understanding as well was that for a part of transaction time, like it was a month or a couple of weeks, there was specific service that was the telemetry was failing or was broken, right? And the team didn't find out until that time passed and someone, I don't know, saw that problem, and then based on that also kind of push the idea on using Tracetest to kind of catch those problems as well, right?
And recently we had another situation where the Kafka link, the Kafka SDK for Golang changed the ownership from Shopify to IBM, and some things changed on this API. So they use a Tracetest to change the telemetry, update this library, and assert that everything was fine. This was other thing that was good too.
Cool, that's so awesome. So just to make sure I understand correctly, when you started writing the trace-based tests, was it so your initial process was basically converting the initial integration tests into the trace-based tests. So you already had like you didn't have to like worry about coming up with the tests. It was essentially a translation, and then you did not just checking for the response, but additional stuff basically.
Exactly. One difference on this approach is that first I started with the language that we all love, that is YAML. So I did a copy and paste on the tests, but when you see traces, you need to think a little bit, what types of traces this API calls does. And what I did was first write a YAML test, run a little bit, and then I swapped it to Tracetest UI, because there we can see how is the shape of the traces that we generate in API call. And I could play a little bit, see, I saw that the checkout service emits this trace that I can assert, the shipping service emit another trace, another spam, sorry. and I could tweak a little bit and start building more complex tests with that, saying, oh, I want to test the service A and see if the service B, D, and E are working as well.
And I think
Cool.
that's a really interesting part of telemetry in general, right? And producing traces and having that all of your services instrumented, because for someone that is not familiar with the system, it's easier to look at a trace and understand the process and the steps that are taken for a specific use case, instead of going line by line, looking at the code and trying to understand what is going on, right? So yeah.
And how long did it take to create like all the trace-based tests, like the initial set for the OTel demo? Because I think it was the announcement was made, I want to say at last KubeCon North America in Chicago, like last fall kind of thing. Is that correct? Correct me if I'm wrong, please.
Yes, it was fast. I believe that also that we discussed with OTel team about what was happening and inspecting the integration code. We were able to, in 2 or 3 days, to build all the tests for each one of the services and start discussing with the opening a PR and start discussing with the team changes and other things that we could do. So.
Awesome. That's so cool. And so like, you know, once you implemented like in implementing the trace-based testing into the OTel demo, like what were some of the big challenges, the gotchas, the unexpected things that you encountered as part of this?
The first thing that we noticed that we thought of is how we could do these tests without impacting the entire ecosystem. And the first decision that we took is we know that this demo uses Jaeger, so instead of we will see the system outside of it. We will just check Jaeger and do every other operation on Jaeger. With that, it was pretty easy to do everything. The only thing that besides that is just to understand the services, understand how they are working, to make our tests. It generated some interesting things, like one service that I noticed that first I thought that the JSON that we sent for the service was in camel case. And later we discovered during the execution of a use case that this JSON was in snake case. So we started to tweak a little bit and start seeing how the things are and do proper tests for it.
When you were writing the trace-based tests, like you said you were looking you're looking at you were using Jaeger as part of your basis. Because I know like trace tests, like I guess there's a couple of approaches to pulling the traces, right? One is either like you pull it like in the collector, so you add a config to the collector, or you can pull it directly from any of the supported observability backends. So what was the approach? I guess my question is, was it the approach that you took then was pulling it directly from Jaeger, like the traces?
Yes, and to that, one thing that we noticed is that since the example sent all all telemetry data to Jaeger, Prometheus, and everything else, we were secure to use Jaeger as it is, because we know that sometimes if you have a huge system, you might use sampling, for instance, to just send a small portion of the tests of the traces for a tracing backend. It was not the case. So this was important because we know that if you have sampling or you have some specific configuration on the collector, maybe you want to do a specific configuration on OTel collector to send some of these traces for trace tests to do the things. But
Right.
it was easier. The job was pretty easy that I thought, since we had everything on Jaeger.
Well, yeah, that's an important distinction too. Yeah, because I hadn't even thought of the fact that if you're pulling directly from the back end, you're basically pulling the traces that were emitted there, versus if you're using the collector, if I recall correctly, you create a different, you create basically a second tracing pipeline, which then intercepts the traces, and then you use those to create your trace-based tests, and then you can put whatever restrictions you want on that, right, for your trace-based tests, which I guess gives you a little more freedom as well, like to play around and configure things.
Exactly.
Cool, that's awesome. And then, on a similar vein, what are some of the benefits that you started seeing after the integration with trace-based testing? Did you start receiving high praise from the maintainers in the community demo, where they're like, "Oh my God, this has changed my life"?
One of the game changer things that I think it was when we saw the OpenTelemetry demo maintainers starting to integrate trace tests on their CI/CD pipeline, because this is something difficult. And I remember at the time that discussing with them, every time that they needed to change something, they did a bunch of manual testing. And since we are humans, sometimes we might forget the testing some service or thinking about an user case. But what they did was, we will create a pipeline, we will build the entire system to see if everything is right. And after building the system, we will run trace tests and check if everything was right. And by doing that, they started to validate some PRs and discover, for instance, that this PR updated a component that is breaking some traces, and with that they could start evaluate and say, okay, let us fix this PR and guarantee that everything is right. And this was painful before, because sometimes you could approve a PR, merge it on the data on the code base, and just 2 weeks later discover that something was missing.
I also want to call out the shout out that we got from Josh Lee. So I remember that when I first joined Tracetest, I saw one of his talks about trace-based tests, actually kind of something similar, or quite kind of what we're doing, and just having someone like him kind of shouting out Tracetest, or what it is and what it means for the OpenTelemetry community, it's just great. So I think that's part of the work that Daniel has done on the OpenTelemetry demo.
That's so great. That's very cool to hear. And now that the trace-based testing has been integrated in the demo for several months at this point, what changes have you seen since that initial integration? Like, even to how you approach trade, like, have there been any massive changes as to how you approach trace-based testing, or is it mostly stayed the same? Like, have there been tweaks that you've had to make along the way?
The one thing that was great is that they started to build traceability tests as they own. I remember that I talked with Juliano, that is one of the maintainers, and he did. When this Kafka thing happened, he told me, Daniel, we noticed that the Kafka SDK changed, and we wanted to create to do some changes on the system and create basically a traceability test on it, and it was amazing. And another thing that we love it was that before we had 3 types of tests running on OpenTelemetry demo: a front-end test using, I forgot the name of the library. Cypress. They had an API call, API test with Ava, and they had trace tests. And they noted, we don't need Ava and Cypress anymore. Since we are focusing on seeing traces and guaranteeing that the telemetry is right and the system is working, trace test is enough for that. And it was amazing, and a huge responsibility for us, because now we know that they rely on us, and we need to have a good API to everything.
That's so cool. That's such a success. And I love the fact, the great thing about the OTel community demo too is that it it showcases OpenTelemetry all with open source tooling, including Tracetest, which I think is so cool and really speaks to the power of open source and the open source community. And you end up with this like really nice symbiotic relationship too, right? Because then you get some more, I guess I would assume you would get some more use cases for improving Tracetest as a whole, based on how you see trace-based testing, acting in the wild through the community demo, right?
During the time that we started to write tests for OpenTelemetry demo, we detected that some of the tests were huge because we needed to embed a protobuffer file inside of each test. And when we started to see that, we noticed, oh, the developer experience is bad for that because you cannot see what is happening. And this moved us to change the CLI and think, let us simplify the test to guarantee that you can see the test and see what matters. And it was good. It was a two-way road. We were able to help the OpenTelemetry team, but the feedback that they gave us helped us to improve Tracetest too.
That's awesome. And as you mentioned, you've got a few folks now writing their own trace-based tests. Have you felt then that like just getting into that mindset of people writing, like other developers writing trace-based tests, have you noticed, like, was that a major shift, or was it like kind of organic once they saw, like, the initial examples that you both added to the repo?
I believe that both things happen for some some developers that were used to OpenTelemetry. They noticed that they could use this telemetry to test it, and it was sometimes is way easier to test. For instance, I cannot think in an easy way to test a Kafka consumer without doing a bunch of code magic behind the scenes, and traces are good for that. So we had some examples of people using serverless, knowing that it's difficult to communicate with serverless components and using Tracetest to help them. And we saw another developer saying, "Oh, we are starting to implement OpenTelemetry, and we noticed that with OpenTelemetry we can test our system quickly." So Tracetest helped them to drive and implement more things on OpenTelemetry and start doing things there. I believe that these two cases happening.
Oh, that's so great. Final question. If you had a redo, would you change anything about how you integrated trace-based testing with the OTel demo?
First glance, I believe that nothing, because I believe that it was a perfect match. So we could do everything that we needed there. The only thing that I think that I could do, and I think that I might do, if you are watching me, Pierre, Giuliano, and company, I will haunt you in the future for that, is to add more tests and start thinking in more interesting use cases that we can do, and thinking more telemetry that we can show there.
Amazing. This is great. We do have a question from the audience. Daniel asked, one of the biggest pains for distributed systems is ensuring correct context propagation across service boundaries, especially when async operations require in-service context propagation across threads, and context may get lost if not instrumented properly. Can Tracetest help identify where context is being broken when it shouldn't?
I think I can answer that question. First of all, I think we have all been there. We have all feel the pain of why is my trace not being propagated to this backend system or this part of the app. And yes, actually, so a great thing or a good thing that we are one kind of standard or thing that we're pushing is TDD, but in this case, trace-based driven development, where users can create assertions and test specs based on what they would expect the trace to look like. So if you already know that after a queuing system, there should be a worker that will process that message, you can pretty much, from the beginning, from the get-go, create a definition that will match a lot would expect and that span to exist. So if that span doesn't exist, it's because the context propagation is pretty much not didn't work, or the span, that's why the span doesn't exist, right? It's not there. So with this kind of technique that you can use, you can validate that the expected spans should be there and help you with the problem of your context propagation problem as well.
Awesome. So you've answered Dan's question. Thank you. And then there was a follow-up question. Can Tracetest make assertions on baggage?
It depends. If you are saying baggage, so for some specific metadata of the OpenTelemetry, perhaps not. But what we can do today is that if you write custom attributes in your span, you define a bunch of attributes, you can test them. You can test them. Also, we are every time looking to the OpenTelemetry specification, seeing if there is more metadata that we should integrate to the API and doing it, like error codes, span statuses, and everything else.
I think we have something about span links, right? I want to do as well. I remember.
Exactly.
Oh, nice. That's awesome. Does anyone else who's listening have any additional questions? This has been really great. Thank you both, Danielle and Oscar, for joining today. This has been really awesome. I think it's really cool. I'm a big fan of the OTel demo, and I think having trace-based testing integrated really, it's like a very tracing native approach to integration tests. I'm a huge fan. So it's super cool to see that integration in place and to see other folks outside of both of you actually writing trace-based tests. Thank you.
Thank you, Luana, and thank you, Adriana, for putting this together and for having us. It was great.